Okay, so welcome to our session with Red Hat, how to reduce costs and manage more data with open source software. My name is Kleiman. I'm a director of big data at Red Hat, and I'll be talking to you about ways that you can save some money by using open source. So I thought we'd answer three primary questions. One is, why is there more data? What's with this big data thing? Why is it creating a problem for me? Why is open source software the best way to address it? And then, why Red Hat? Because there's more than one choice, obviously, when it comes to open source software. Feel free to ask questions as I go through, and if we don't ask any, then I'll ask you some questions at the end. So let's get started in terms of why big data. So there's really three things going on. Obviously, the data is overwhelming, it's breaking the infrastructure, and you've got, if you're in IT, building big data solutions, you've got lots of people coming at you with different requirements. That creates challenges for you. So the first one, in terms of data being overwhelming, I think this is fairly obvious, but just to be clear, data's doubling every year. IDC says we're headed for 8 zettabytes by next year, and all that data is really, the bottom line is the quantity of data is creating information overload. So agencies in the state, private industry, just people like us, we're getting barraged with data, and it's kind of overwhelming us. So that's the first thing, and that creates part of the problem. The second is that mass of data is also breaking our infrastructure. If you follow the CTO of the CIA, he had an interesting way to put it, which was the challenge here is to try to make 7 billion a small number. That's the number of people in the world. Right? The thinking is everybody's going to have devices, everybody's going to be generating data 24/7, 365 days a year. We got to figure out how to make that quantity of data small so we can manage it. If you look at some of the folks who are already in that category, Google's over 100 petabytes, so's Facebook, YouTube's approaching 800. They all have that problem, as well as on an even bigger scale than some of the state agencies. But if you look at what they've done, all of them have gone with commodity hardware and open source software. And that's because traditional infrastructures break. They can't handle the scale. To give you, again, going back to the CTO for the CIA, he did a good job of pointing out, there's basically kind of a tectonic shift here with technology given that mass of data. All the traditional things, usually you're used to putting data on your SAN, that just doesn't work at big data scales. You have to put it in the processor. So everything we thought used to work doesn't work anymore. You have to move your data and your application into the server. You move the backup doesn't work anymore because there's too much data to back up. You physically can't move that much data in the time window that you have, so you have to go to more of a replication strategy. Everything has to be horizontally scalable. DR doesn't work anymore. Tape doesn't work anymore. So sort of on the hierarchy of storage, everything moved up to the next level. So what used to be on tape has moved to SAN, what used to be on SAN has moved to disk, what used to be on disk has moved to memory. So at that scale, that's kind of the only way you can manage it. And that basically means you got to have a new approach to your infrastructure. The old way will not work. And finally, just to make matters even worse, you're overwhelmed by data, your infrastructure is breaking, and you got different people coming at you with different requests. So the business analysts, who are the people who are trying to solve the business problem, they're trying to get an answer for you, they're coming to you saying, I got all this data, I want to put it all together, it's coming from different places, but I want you to get it all in one place so I can analyze it. And I'll talk some more about that. Then you have the developers who are trying to struggle with new tools, new analytics packages, and they're trying to develop the apps for the business users, the analysts. Then you have your data architects who have a similar problem. They have data coming in from everywhere at high volume, and they need to put it together so that the analyst can look at all the data together, not just in silos. And then obviously your operations team is dealing with the stuff on the previous slide. They're trying to build an infrastructure to support all of that data and to support the business analysts so that they can do their job and get the answers and drive the business. So that's a hard challenge. So let's talk a little bit about, well, if that's the challenge, why is open source part of the answer? And there's really 3 reasons. 1 is cost, 2 is flexibility, and 3 is community. And let me drill into those one at a time. So starting with cost. Obviously, open source is nice because it's free. But we all know nothing's free. Even though it may not cost you money, it's still not free. But the good news is that it runs on commodity hardware. So you're basically, if you use open source and you use commodity hardware, you're doing exactly what the Googles and the Facebooks have done. So you're following something that you know works, because they're already at that scale. And they're operating it on a daily basis. So as usual, you want to copy what everybody else is doing that works. 2, and this is critical, again, follow the people who did it, is you can modify the source code. That's a very important requirement when you get into big data. You have, Department of Transportation has a totally different workflow, totally different ecosystem, different applications, different business need than the Treasury Department, right? Different things, you have to be able to adjust it, given the amount of data you have coming in, you have to be able to modify the source code so that it works for you. And that's an important characteristic for open source. And then finally, and this is probably the most important one, is you're going to be putting together a whole bunch of pieces to solve this business problem, right? You're going to have data coming in from lots of places. It's going to get fed into different silos at different times, at different rates. You have to give that business analyst that view of all the data that's coming in. The only way you're going to be able to do that is if you have pieces that can interoperate with each other and they can talk to each other. If you build silos, it's not going to work. That's sort of the old way. And that's why open interfaces that open source has is critical, and it's the only way that you can keep your costs at a reasonable level and still make it work. Okay? So if you look at, pause for a moment and look at Red Hat, we have a lot of those characteristics. So if you look at the Red Hat portfolio, everybody knows the thing at the top. Everybody knows Red Hat Enterprise Linux. But Red Hat has a lot more than that, and you need a lot more than that if you're going to solve the big data problem. Related to platform, not everything can run on physical hardware. You also are going to want to virtualize some things, and you're going to want to run some things in the cloud. As I mentioned, the big data, right? A lot of data, you have to be able to spike up to meet the demand, and then go back down again. So you need an elastic infrastructure. So things like cloud, and specifically Hadoop on the cloud, and having that in your private cloud, not using Elastic MapReduce on Amazon where you can't really put your confidential data. Running that on the private cloud like OpenStack is a key enabler for you to solve this big data problem in your business. Obviously, when you're talking about lots of data, you have to have a storage platform, and Red Hat has that. And we have plugins for Hadoop. If you choose to use that platform, we also have plugins for other things. And I'll talk some more about that. And then finally, I talked about the need to put different things together into your specific workflow. We have middleware products as well. We have the Jboss family. We have data virtualization and Jboss Data Grid, and I'll explain how these kind of come together. But that's the product side, but it's more than that. As I mentioned, one of the other things you have to be able to do is you have to have an open community, right? Because no one vendor is going to be able to solve all your problems, and no one platform is going to solve all your problems. So by interacting with the community and working with Hadoop community, with traditional enterprise applications, as well as the open source, we have, Red Hat has contributors that contribute code in all those places. So that we can influence it, and we actually have a project in Fedora, which is the upstream open source community behind RHEL, to put Hadoop on Fedora, and that's driven by Red Hat engineers. We also have some contributions in Apache, which I'll talk about in a little bit, in the Apache Hadoop community. So in the usual Red Hat way, we are engaging with the community and trying to leverage that expertise, because we know we don't have it all. Okay, so going back, we talked about cost effective. All of that drives your cost down. But you still need that flexibility, right? Because just free is not good enough. You have to be able to modify things to meet your business needs. And if you only remember one thing from this session, this is the one thing I want you to remember. It's not all about the data. It's about your workflow. It's about your business problem. that it's big data, who cares? It's just a bunch of data. What matters is you getting business value from that data, right? And that's where the vast majority of the customers that we talk to, that's the core of their challenge. They have the data, they can stick it all in a bunch of hard drives and keep it in their infrastructure, and they have the analytics, they know what they want to get out of it, and they have a big gap between those two. That's the hardest part about big data. But the key to solving that hardest part is understand your workflow, understand what you want to get out of it, and then modify everything in between to fit your process, to fit your workflow. That's the key to big data. So it's not about the data, it's about the workflow. So you have to sit down and do the work with your data architects and those business analysts and understand, okay, what would help you? What's the question you want to ask? What are the data sources you need? And you need to bring that together for that business analyst. That's our job as big data solution providers. And that's the key, is to take all that information, reduce it down, and present it up to the business analyst so that they can answer the question and take all that data and turn it into actionable information. Because data by itself is not terribly useful. What you want to do is transition that into a business action that you can take to improve something. Okay? So I'm going to walk you through some examples as well. So that's the key, is that flexibility, to have an infrastructure, to have a portfolio of products that you can put together on an as-needed basis to solve your specific workflow problem. So this is an example of how you could put some pieces together. Some of these are Red Hat and some of them are not, but let me take a moment to explain this. So at the very top is the most important part, and that's the business analyst. So that's the person who has a business question they want to answer. So it might be, okay, I'll give you a couple of examples. So you might want to combine some Facebook and Twitter information with some order history with some machine data coming in from the field. So structured data would be in the bottom on the blue there. That would be your traditional order systems, right? Those are structured databases, RDB, transactional systems. They've got the information, though, about that, where's the money flowing, where are the transactions that are happening, but you almost always need that data in order to make the big picture. Second is streaming data. So we all know there's lots of sensors out there. There's cell phones. There's that are sending data in depending on which business you're in. There's almost always some real-time data coming in. So if you're in Treasury, you have market feeds. If you're in transportation, you might have sensors in the road. But in almost all areas, you're going to have machine data being generated by machines coming in at a very high rate, and that's your streaming data. And then finally, your semi-structured data is all of the web stuff. So that's your Facebook, your Twitters, your Google, your click streams, etc. So your idea is that you want to combine all those together and look at all of your data in order to make a decision and to answer a business question. So you need a platform that can span all of those. So Red Hat Enterprise Linux can run all those workloads, as well as Red Hat Storage. And it can carry the data through your workflow. And that's a very important foundation that you'll need. Also, cloud could be there as well, something like OpenStack. Then you're going to need some middleware to get the data parsed and filtered and routed to the right place at the right time. And that's where some of the red stuff in the middle is. So Jboss messaging and event processing would grab that streaming data, because it's coming in real time, and messaging is usually the best technology to route that, and send it to the right place. Hadoop is a great tool for doing batch analytics, so that's almost always a piece of the big data picture, but that's not the only piece. Jboss Data Grid is an in-memory database. Often we find a lot of our customers want to do some amount of analysis in real time. And that's what the Jboss Data Grid does, because things like Hadoop can't operate on real-time data in the speeds that it has to have of the data that's coming in. And then finally, Jboss Data Virtualization, at some point you need a common data model, because you have to take all of those different data sources, which are in different formats, right? Your SQL data in your transactional system is completely different than messages coming in from sensors in the field, which is completely different than unstructured data coming in from Facebook and Twitter. You have to create a common data model across all of those. So that's what Jboss Data Virtualization does. It takes lots of different things from all these different data sources, creates a common model, data model, and presents that up to applications and to analytics so that they can look across all their data, not just a single silo. Okay? So that allows you to start to put together a complete solution that can take lots of data, the big data, but get some action out of it, make some decisions about it. Okay? And this is very much of a puzzle that you will pick and choose the pieces you need for your workflow. Again, going back to that, if you only remember one thing, that's the key. You got to make big data work for you and your workflow. So some of these will work in some cases. You may not need all of them. You may need all of them. But the important part is to figure out your workflow, figure out what your analytics flow is, where's the data coming from, what types of data, and how can you put it together and pick the right pieces that you need for your specific workflow. That's the key to succeeding with big data. And as I mentioned, that's why you need those open interfaces, and you need you need access to the source code sometimes. You need interfaces that interoperate with each other, and you need that complete suite of middleware, OS, infrastructure, and storage. And finally, you usually can't do it all yourself. And so the best thing you can do, especially in government, is leverage what's happening outside. And that's community innovation. That's what Red Hat is built on. That's what RHEL is built on. We believe 150% in community innovation. And the best way to do it is you open up your code, you share it with everybody, and you'd be amazed at how much quicker you can innovate when you have people around the world all accessing and testing it. At the end of the day, right, the quality of the software is mainly determined by how much testing you get. And when you have a community of thousands of people around the world all testing it from their own perspective, you're almost always going to get higher quality code in a shorter period of time. And that's, at the end of the day, that's the real value of the community. And then everybody's going to take it in their own direction, which is a good thing, because that will create the innovation. And so Red Hat is involved in a lot of different communities in order to provide that solution for big data. So I'll talk about a few. Origin is the OpenShift, that's platform as a service. And we wholeheartedly expect to move big data into a platform as a service where you can spin up instances of Hadoop and other big data analytics and do them on the fly for your developers. And that can either be hosted inside your cloud or outside. OpenStack is a cloud, open source cloud initiative that Red Hat's very involved in. Again, there's a Hadoop on OpenStack project already underway. Red Hat's leading that. Involved with a couple of other players in that space, Hortonworks being one of them. And that's really all about big data on top of a cloud infrastructure to give you that elastic MapReduce capability in your private cloud. Amazon Web Services is a big partner. We run RHEL, we run Red Hat Storage. All of our technologies can be run on Amazon if that's where you choose to run it. We obviously have Fedora. That's the open source community behind RHEL, and there's a big data project there for putting the big data and specifically the Hadoop infrastructure, things like Pig, Hive, MapReduce on top of Fedora. So that, again, we can take advantage of the community and get the innovation. Jboss also, all that middleware pieces that you saw on the last slide, those are all driven by an open source community as well. We're very involved in Hadoop. I think I have a slide to talk about. We're a contributor to the Apache Foundation, and Gluster is the open source community behind Red Hat Storage. Again, we want people to use it. Actually, Facebook uses Gluster. So you saw that 100 petabyte number. They use Gluster. So the technology that's behind Red Hat Storage is pretty well proven at scale. These are some specifics on our involvement. I talked about Gluster. There's a Hadoop plugin for Gluster already available, has been for a couple of months now in the upstream community. For Apache, Red Hat has contributors that have made changes to Embari, which is the open source management framework, to allow other file systems to plug into Hadoop, in addition to Red Hat storage. So we wrote the handlers and the code in order to use non-HDFS file systems with Hadoop, and we contributed that to the community so everybody else could leverage it. Fedora I mentioned, and OpenStack I think I mentioned already. So these are just some examples of how Red Hat is engaging upstream in the open to try to drive innovation and solve the big data problem. So, if you're convinced now that we got a big problem, the best way to solve that problem is to follow the people who have already solved it, and they have all used open source. So open source is the best path forward because it's cost-effective, flexible, and you can leverage the community. The last question is, well, okay, why Red Hat? Because there's other open source alternatives. And I think there's 3 reasons. One is we're the largest. We're the most successful open source company in the world. We're $1 billion company. There's nobody else in open source that's anywhere near that revenue or scale. As I mentioned, we've got a very comprehensive portfolio, from middleware to cloud to storage to operating system, and you're going to need all those pieces as you try to solve this big data problem and make it specific to your workflow. And we're always upstream first, so everything we do, we release upstream first, and then we pull it down. So it's always available for the community to innovate on top of, including government agencies. And we've been delivering that for many years to demanding enterprises. So all of our business really is enterprise, not open source. Our value is taking that code, that open source code, hardening it, and making it available and supporting it globally to large organizations like the government. So we are 100% open source. That is all we do. Second is, as I mentioned at the beginning, our stories and our products are big data ready. So what I mean by that is, when you get into the big data projects, you're going to find a range of people that are going to start asking for things. And I mentioned these up front. There's business analysts, there's developers, there's data architects, there's operational people. And Red Hat has products in all those areas so that you can go back to them and say, okay, your business analyst is saying, look, I got to combine these different data silos into a single workflow, and I'm struggling with that. We've got Jboss middleware to help with that. The developers are trying to develop the apps for those people. They have some of the same problems. Again, we have Jboss development tools. We also have OpenJDK on RHEL. Again, everything's open at Red Hat. Your data architects who are trying to actually put all that data together in some way, we have Red Hat storage that can span those different silos. And then finally, on the operational side, we have RHEL, and we also have RHEL OpenStack platform. If they want to go either cloud, we can go physical, virtual, or cloud. And we span all 3 of those deployment schemes. And so you can mix and match those and still maintain the same Red Hat platform. So we're ready for kind of that complexity of the big data problem. And then finally, at the end of the day, you're going to need something that's supported at the enterprise level. Red Hat's been doing that for 20 years on a global basis. We've got lots of big customers around the world who have pushed us for 20 years, and so we kind of have the support organization to do that and execute that for government agencies as well. And our real value is in our engineering. So we take that code from upstream, we pull it down, we test the heck out of it, and then actually probably one of the biggest values is the packaging. We make it simple. We decide which things all work together, we test them, and we package it so that when you get it, you can just click and go and install. You don't have to deal with the complexities of going upstream where you have to put it all together yourself. We do that testing and package it so it's easy for you to deploy it and maintain it. And then we obviously support it. So that's all I had. I think we got a couple of minutes for questions. Any questions? Yeah.
When you say the packages, is it for the particular individual package, or is it just standard? It's a standard package.
It's a standard package that we do have customers that customize it. So it usually comes as an RPM. Or it can come as an ISO. A lot of our customers, though, they they use something called satellite, Red Hat Satellite, which is a mechanism that allows them to download the package, install it on a server, and then it automatically updates, and they don't have to do anything. So that's what I meant by packaging, yeah. But the key is, like when you're putting together an operating system, or actually middleware or storage, is to assemble all the pieces, because as you would imagine, when you install an operating system, there's probably 50 RPMs you have to install. We figure out what are the right 50, we package them and test them together, and then we give you the one package, one RPM to install. That's the value, yeah. And same thing on any of the products, middleware, storage, OS, cloud, it's all the same approach. We try to take that complexity out. Is there a question?
Do you have a package like Hadoop or Cloudera package?
Yeah.
They have something similar to that?
We do not have our own Hadoop distribution. We work with Hortonworks, Intel, Cloudera, et cetera. So you buy the good example would be, you would buy your distribution from Hortonworks, let's say, and you would get the Hadoop part from them. You would buy Red Hat storage from us, and then what we do is we make sure you would install Red Hat storage first, and we have that's what those Ambari changes are. When you install Red Hat storage, it gets it ready for Hadoop, and then you lay Hadoop on top of Red Hat storage. And actually, one of the values of Red Hat storage is it's one node. So you have one physical server, commodity server, you install both the storage and Hadoop, and you run your Hadoop on top of your storage. So you have local disk access just as you would in a Hadoop cluster, but you have all the advantages of a more scalable, more interoperable storage platform. Other questions? Okay, that means I'm going to have to ask you some questions. How many folks are here from government agency? Everybody. Imagine that. Yeah, we're in Sacramento. How many folks have big data projects underway right now? Only a few. Interesting. Okay. For those of you that don't have projects underway, are you interested in this area, or it's not a need right now? So who of the people who didn't raise their hands, how many are looking into it because you think you're going to have one soon? Okay, a few. Okay. As you look at big data, what are some of your concerns? Yep. Yep. Right. Right. Yep. Mm-hmm. Yeah. And that's a pretty common thing that I've seen, and that's why some of this stuff is important. Because, like I said, the key is actually in the middle, right? A bunch of data, as you said, right, having lots of sources coming in, that's a pretty common thing. What you need is a way to put that together into a workflow. It sounds like that you would agree with that. Right, exactly, because the problem is when you have that much data, the brute force doesn't work, right? Okay, other challenges? For the folks that do have a big data project, any lessons to share with the people who don't or haven't yet?
How about selling it to an organization that already has a number of enterprise systems?
Yeah.
Aren't being used and
Mm-hmm.
So how do you tell them here's another enterprise product that we want to push through to implement it, but all of these other products, all that stuff is possible.
Right. Yeah, so the way that I've seen that conversation go and work is to say this is a different approach, right? We're not going to use the traditional way. It kind of goes back to this slide, which is, things are changing, and the EMCs and the VMwares and et cetera, they're kind of on the left, right? They're approaching it the traditional way, and that's not going to work with big data. So the way I would sell it would be, hey, we got to take a different approach because the old way isn't going to work. So, let's take an open source approach. Let's do what the people are doing that have this problem already and have had it for a couple of years. Let's go try open source, right? It costs us less. It costs less to get started. You can try out things, right, at a pretty low cost. And as you said, right, some of it you learn as you go. And it doesn't cost you an arm and a leg up front to try to learn. You can get started, try things out, create a sandbox, try some projects, try some analytics. That's the way that we've seen it work well, is you pick a little, fairly classic, right? You pick a little problem, you go solve that one using in a very low cost way, and then you go back and try to make it bigger, right? And solve a bigger problem with a kind of a grander architecture once you prove something out in a small case. Other questions? Okay. Well, thank you all for coming. We appreciate your time. Enjoy the show.